Hi there, Econ 140 students. So real quick, I'm going to go through the steps for part 2 of the lab assignment that we have today, this week. So this is lab 4, looking at dummy variables, just 2 problems, one with the H price data set and one with the wage discrimination data set. So I'm going to go through, I went through it in Stata, now I'm going to go through it in Excel just to show you how to do it. So the first thing you want to do is open that wage discrimination data set. You can get it from the textbook website. You can also get it from Canvas, and go ahead and get that open. And this is a constructed data set that looks at salary in thousands of dollars, education in years, experience in years, and then sex to look at whether or not there is wage discrimination. So once you've got your data set open in Excel, I'm just going to get rid of this column because I don't know why it's there and I don't want it there. What you want to do is, this is going to ask us to do 3 things, this assignment. Oh, there's my other Camtasia video being done. So we want to go through and look at summary statistics. Because calculating summary statistics in Stata is different from Excel, you don't have to summarize everything. You just want to go through and get the mean for salary, education level, and male, and that's going to give you the answer to those first 3 questions. So I'm going to go ahead and put them over here. Let's do mean. I'm going to put that in bold. And when you're doing stuff in Excel, your Excel spreadsheet can be your answer sheet as well, right? Your submission. And how you want to order that is really going to be up to you. So I'm going to go ahead and try to make it as straightforward as possible. So I'm going to have mean of salary, mean of education, mean of experience, and mean of sex. And then I just come over here, and remember the command for mean is =, average. And then you want to select the data that you're using. And so I'm going to select salary from 3 all the way down to 102. And scroll up, and that gives me a mean of 22.410. And then here for education, I want to do the same thing. And I want to go from B3 to B102. I'll make sure that's the right, yep. And I can actually go ahead and do the same thing for experience. Now I'm looking at C3 to C102. And finally for sex, D3 to D102. And so now I can say that, I'll put a little box here to explain my results. I'm going to merge and wrap my text in this box. So that what I did just here is I selected the area where I want to put my response, and then I clicked merge center and wrap text, and that's going to basically make me a little nice text box. And so I'm going to put part A, the mean salary for this sample is $22,410. The average level of education is 2.88 years, and the average experience level is 1.19 years. Because sex is a binary or dummy variable, and D = 1 implies male, the mean of 0.31 tells us that 31% of the sample is male. So that's part A. So far, so good. Because I'm a little bit finicky, I'm going to go ahead and change the orientation of this data. You guys don't have to do that. I just get picky about this stuff. I like everything to be centered because I'm a little neurotic. So that's the first part, right? The next part we want to do is, okay, go ahead and for part B, we want to run our first regression. And our first regression is going to be a simple regression of all of our variables. So it's going to be reg y, x1, x2, and d1. And so I want to go ahead and go to data, do a data analysis, and then I want to get regression. Okay. Select my Y input range, which is just going to be all of the variables for salary. That same range that I looked at before. For my X variable range, I can select the area that includes years of education, experience, and sex, or I can just type it in. So it's going to be $E3, and that's going to be that upmost corner of the selection, colon, $D102, which will be the lowermost section. I don't have data labels in my variable, so it's just going to show up as x1, x2, x3. I want to keep my confidence interval at 95, and then I'm going to add in a 90% confidence interval because I can in Excel, which is great. And then I want to put my output here in my same sheet so that I can see it all together, and I'm just going to pop it in right there. Okay, and then go ahead and click OK. And there are my regression results. And so I can come in here and see my R squared. I can look at my regression sum of squares, my sum of squared residuals, and my total sum of squares. My model explains about 86.22% of the variation in salary, which is great. And then I can come down here and look at my p-values, and I can see that my p-values for my x1, which is salary, or sorry, is education, is equivalent mathematically to 0. My p-value for experience, my second explanatory variable, is equivalent to 0. My p-value for sex is very, very high. And so when you go ahead and interpret your significance for that, which is one of the things I ask you to do, run the multiple regression analysis, report your findings addressing the issue of wage discrimination in this occupation. Are your results statistically significant? Well, the marginal effect of education and experience are statistically significant, but the marginal effect, or there's not a marginal effect, but rather the explanatory variable of sex is not statistically significant, right? The p-value is high, the t-stat is low, the standard error is very high. And if you look at both the 95% confidence interval and the 90% confidence interval, they both contain 0. So we cannot reject the null hypothesis that sex is not statistically significantly different from 0. So the effect of sex on salary is not statistically significantly different from 0 to our knowledge. So you can go ahead and interpret those coefficients. You can create a little box like this and do that, where you would just kind of go in here and I'd say, okay, maybe here I'd say, go to home, and I'd say merge and center, and then wrap text, and I'd say part B, the estimated coefficient is not statistically significantly different from 0, but the explanatory variables education and experience are. And basically, you know, if you go through and estimate these, you'd talk about the marginal effect of an additional year of education. So the marginal effect of an additional year of education here, that's our estimated coefficient, is going to be each additional year of education is going to tend to increase salary by $504.60. And that's because, remember, salary is reported in thousands of dollars, and you've got your units right here. So one year of education is going to increase salary, is going to tend to have the effect of increasing salary by $500, holding sex and experience constant. An additional year of experience is going to tend to increase salary by $766.41, holding education and sex constant. And then here we have the explanatory variable sex, which is our dummy variable. I'm going to call it D. And we could say that the effect of being male is going to tend to decrease salary by $267, give or take, holding education and experience constant. So what that's telling us is that there's actually a salary burden associated with maleness. So we'll talk about that more. But then the next thing you want to do is create the interaction term. And so what we want to do for the next part is I'm going to make a little space here, and I want to create my interaction term, sex times experience. And I want to call it Z. And then the formula for that is going to be equals to sex times experience. And so the formula is you put in the equal sign, and then you want to put in the value for your D variable and the value for your X variable. So in this case, it's X2 and D1, or experience and sex. And so I've done it this way. You can reverse the order. It doesn't matter, but that gives you your variable. So this person is male, so their 3 years of experience count. This next person is female, and so their interaction term is going to be 0 asterisk or multiplied by years of experience is also 0. So that's going to be a value of 0. You don't have to do this every time. If you come over and select this one variable where I've got my equation built in, and then slide your cursor over so that it turns into a black plus sign, that allows you to click and drag the formula all the way down so that it will calculate all of them for you. And then you can look and see here, and it's really clear. If my value is 0 for sex, then my value for experience is 0, no matter what. So here's someone with 1 year of experience, but they're female, so it's 0. But if you're male, then the value for experience is whatever your experience level is. So what we're doing is we're separating out experience for everybody. We're pulling experience for males out from experience for everybody. And that's going to allow us to get some more information. And if you want some more detail in terms of the explanation, you can go ahead and take a look at the Stata video for this too. I think it's useful even if you don't get to use Stata right now to sort of see the output, see the process, and see some of the other data. This is really just to show you the commands. So here I would go, and I want to go now and generate that next regression. So I'm going to make a little note here that this is C, and it's going to be the regression of Y on X1, X2, D1, and Z1. And then go ahead and go to data analysis, regression. And now what I need to do is I need to expand, and everything's already in there from my last regression. That's kind of the nice thing about Excel, is it remembers what the last regression you ran was. So it's got my input range, and it's got my Y range, it's got my X range, and all I need to do is extend it from being B to D to being B to E. And now if you look at it, it's this whole area is already selected for me. And so that was a really easy change. I'm going to change my output range to be down here, so it's just be a little bit lower than my original output from my first regression, and then go ahead and run that regression. And here are my regression results. And so the first thing we want to check is the statistical significance. And we can see that sex is still not statistically significant, right? But what is statistically significant is our new interaction term, right? So this is our Z term, or our interaction term. This is sex, this is experience, and this is education. So what that's telling us, because Z is statistically significant, it's telling us that Z has explanatory power. So our regression was less good at explaining variation in salary without that variable. And we can also look to our R-squared and see it. Our R-squared went up by a little bit. Not a ton, but a little bit. So we went from having an R-squared of 86.22 to an R squared of, 86.89. Sorry, I didn't mean to shrink that for you. There you go. So now you can see that. So our interaction term is statistically significant at the 95 and the 90% significance, or at the 5 and the 1% significance level, at the 90 and 95% confidence interval. And what it's telling us is the marginal effective experience for everybody is $1,387.36. But the marginal effect of one more year of experience for men is a salary cut of $644.22. And so what that's telling us is the marginal effect of experience is different for men and women. And that gives us new information we didn't have before. And that's the real value of these interaction terms, is being able to see the difference in that marginal effect. So I would interpret these as saying the marginal effect of one more year of education is $507.79, holding experience and sex constant. The marginal effect of one more year of experience if you are not male is $1,387.36. And the marginal effect of one additional year of experience if you are male is going to be equal to the marginal effect for everybody plus this additional marginal effect that's just for men. So that's going to be an additional $743.14, give or take, for men relative to what the marginal effect for women is. Okay? So take a look at that. Take a look at the home price data set. You can do the exact same things. You want to remember the big deal is to remember how to run your regression results using that data analysis tool. And then here that the formula for generating your Z term is just going to be equal to the multiplication of your dummy variable and your quantitative variable. Okay? Make sense? If not, let me know. Otherwise, have a great day, and I will see you guys all next time. Okay. Thanks so much.